So we're going to look at one of the ways you can use Pythagoras' theorem to find the lengths required in a triangle. So this triangle I've actually drawn reasonably accurately, so we're going to use this by measuring and doing all the steps. So what I'm going to show you today is how to work out the long length without measuring it. Now, because this is accurate, I can measure it after to see if it works and show you that it does work. This length here is 77 millimeters. And this length here is 102 millimeters. So you have to spot that this is a right angled triangle and we're being asked to find a length. And that should make you remember Pythagoras' theorem exists because you've seen it before and you've practiced it obviously. And you then have to remember what Pythagoras' theorem is. Well, that says if I label this as A, this is B, and this is C, remembering that the longest one is always C, because that's got a proper name, that's the hypotenuse. If I square these to find the area of a square that would sit on their edges and add them, that must equal whatever C squared that square would be. But I don't want to know the area of the square, I want to know the length. And you have to recall how to get back from an area of a square to its length. What operation gets rid of this square? It's the square root. So if you have a calculator, you don't need to do any maths in your head for this. If you haven't got a calculator, or you've got a calculator that isn't fully scientific with all the brackets and stuff, you might want to do some steps before. But you don't need to work this bit out beforehand if you don't want to. I think it's quicker not to. We're going to square root this. So we're going to get the square root of all of this stuff. And that will be C. Now, if I run that through a calculator, making sure to type it in properly, which can cause some issues, I want the square root of 77 squared and 102 squared. And you see that's all under the square root. That will give you this decimal here, which we can round to something sensible. I might just round it to 128. Round it to the nearest whole millimetre, as that's probably as accurately as I can measure. So if this really is a right angle, and that really is 702, and I measured it correctly, this paper is really flat, this will be 128 millimetres. So let's see how accurately I drew this, or how flat the paper was printed as. So we get that lined up there, and lo and behold, we have got 128. So that is 128 millimetres, so it's not a fluke, it does work. And of course, the whole beauty of doing this thing mathematically is you don't need to measure things, you can just use the algebra to work it out for you. So we're going to do this quicker, without any measurements because it's been given to you. Now I hope it's obvious to you that this bit of paper really isn't 45 kilometres across, so this can't be a real size drawing. And in fact I've not even bothered very hard to make the right angle accurate, because the whole point here is if you know that's a right angle really, you can use the theorem. And the steps here were to square stuff, add stuff, and root stuff. Okay, so we're going to have 10 squared and 45 squared and root it. And that's it done. That is a number. You don't know what it is yet, but your calculator certainly does. That is the length of P. And that's all there is to it. Now, some of you who might know where this is going are screaming at me why I'm just glossing over the add. Remember that this length here is longer than these lengths. So it's got to be more than we started with. We've got to add these squares to get the big square. Now that might give you a clue as to how we find other squares later, but we take the smaller squares, add them, and then square root them and turn them back into lengths again. And there you go, there's a number. Now it's giving me a surd here, but I can press the conversion, and that is roughly 46.1 kilometres. So that is the length of P. And that's it. Square, add, root, done. You can find the longest length in a right angled triangle with that simple process. Enjoy!